Hello guys, in this video I'll teach you how to install and start your first video analysis using the tracker. This is a free software you can download using this link. I'll put the link in the description below. Some people may try to compare this with the Logger Pro software because Logger Pro can also do video analysis, which by means is you analyzing a video and try to find out a certain object's position, and therefore the computer or software can calculate the velocity and acceleration, etc. And this is a very useful way for analyzing mechanics motion, and it will be very helpful for physicists to analyze certain motion. But Logger Pro is a paid software which you may not have access to it. So in that case, I would introduce Tracker instead. So as you can see in the website, you can download the installer here. If you're using Windows, go for the first one, MacBook the second one, and if you're using Linux, go for the other two. Because of the time, I've got the installer already. And once you run it, you would soon see something got pop up like this one. And because if you have installed it already, then you see this. But if you are newly installed, then you shouldn't see this. So I will reinstall again, and just you have to agree the license thing, select the path. This is one thing that I would like you to click. So for this one, once you click it, then you will also install the library for the videos that they provide, and that should be it.
A few moments later.
Okay, so once you finish, you see this and you just click finish. And this is just for your reference, not very important. And if you didn't do anything, then it should start the software automatically. To start off your new video analysis, here let's do this for a practice. So you can see there's an icon here which I want you to click into it, and you see under this folder called videos there are a few different files that you can open. So what I want you to do is go for the ball toss out, that one. You just simply open it. There's a note for you, but you can just ignore it for now. We'll explain more about like all these things maybe in the next video. And so if you can see this, and if you click the green button here, you see simply a ball score toss out like this. So nothing really special, it's just like watching a video. And so for now, what I want you to do is we of course can start to do what we should be doing for pointing out maybe different points on the object. So like you can try to do for different frame, which you can kind of locate the ball position. But then before that, I want to show you how exactly it look like before you when you finish it. So back to the open that icon, you may want to go for one folder earlier, and you can see like just now we were in the video folder. So if you go to the experiment folder, you can see there are so many files, actually the same kind of files, but then they have got the file name as TRK at the end. TRK is actually a special file format for the tracker software itself, which means when someone tries to pinpoint some objects like finishing the video analysis, they can save the file together with all the information. So there's actually a same file which called the ball toss here. You open it and you find exactly the same thing. Again, there's a note which you can ignore first. And so you can actually switch from between these two. You can see on my bottom left here, this was the unfinished one, and the TRK, that one is a finished one that has been done by the software developer. And then you can, if you try to drag around this, you'll be able to see it has been already been done, which is something that I will want you to do later on with the raw file. And also you can see on the right hand side, the graph has already been done automatically here. So this is the most powerful part from the video analysis software. And you can always change the XY axis also. So this you can see here is the X, that means a horizontal displacement against time. And also we can also try to do the Y, so this is like a projectile motion vertically. And we may also want to study the horizontal velocity, which although you may think, hey, this is a strange shape, but if you look at the y-axis, it's actually ranging from 1.7 to 1.83. So you can actually right click and zoom out, and you can see it's actually quite constant. All right, of course it's not perfect, because maybe sometimes when you try to locate the point, like it may be a bit off. So that's why you can also try to see the vertical speed, and you can also try to make use of the auto scale, so you can have a nice shape of it. And you can also see this one is a very nice graph where the slope is straight and negative. So that actually means it shows there's a negative acceleration. Okay, and you can also double check it by changing it to acceleration for y component, which you can see again the graph may looks a bit strange, but if you look at the y-axis again, or if you try to zoom out, you can see it's mainly at -10. Okay, so that kind of coincides with the idea of the gravity is around 9.81. Of course, I don't know why it's a bit longer. Maybe it's because of the scale when they set it is a bit off. It's a bit more than what it should be. Other than that, you can also see on the bottom right, you can also find the raw data for the X and Y position with the specific time. You can also try to change if you want change for other things, like for different views, to make yourself more comfortable. Okay, so this is the basic idea. So now let's take a look at the icon panels here and see what the functions they are. So the first one is like what we did for opening file, nothing's really special. The second one is save them as the tracker, so like I said, the special kind of files after you finish it. The third one is interesting. So what you can do is there's a library where you can find from this software, they also has stored some sort of online videos where you can find it. So say under this one you can double click it and you can see there's a file like a worksheet or some instruction you can follow, and then they will also have the file for you for the video. So it's up to you where you want to find more practice for you. So let's just close it for now. For the fourth one, you can also save it as a file where you can put online. So that's why they group these two together. If you want to upload and share your video as a project, you can also do that. The next one is for the clip setting. So normally I don't suggest you to change it because the software should have detected the video that you import, so it shouldn't be a big issue. The next thing, this one is extremely important. So when you click it, you can see right here it pop up something called the 1.000 meter here. So this is the most important part in video analysis on how it works. It's just mathematics. Think about this. You have the scale for this one. So as we all know, if this is 1 meter, then we can basically see how the ball moved in the video. Of course, one assumption would be this ruler or whatever it is will be on the same 2D plane of the object. So that is to say the ball is moving onto the same background of the ruler as well. Okay, or at least they are very, very close. So that's why just now I said the reason why maybe it is more than 9.1. So you can see it's like -4, 10.4 or something. It's probably because this is a little bit too long. So you can actually adjust it, and I can make it shorter, and then I can claim this is 1 meter instead. So probably that will affect the whole data setup. The next thing you can see here is about the coordinate. So you can always select and choose where the origin you start with. You can also actually change the angle as well. So for sometimes, as you know, maybe the object is on the inclined plane, then you may want to set the coordinate with certain angle, then this may come very useful. But of course, for now, I'll go back and set it back as 0. So you may also want to use your shift button on the keyboard so that it kind of go, you can see now, you can actually look at this one, right? When I press this, it go with a 5-degree interval, but if I don't press it like now, it go in a more continuous range. So I want to be exactly 0 degree actually. The next thing you want to do is you can create a new track. So that is what you do for a raw file. For the ball, you may want to count it as a point mass. For object that you may consider is moment, then you may need to use the center of mass. And for the rest, you may look into it in the future. The next one is the panel. So nothing really special. Sometimes you got two objects moving, so you may get to use it. The next thing is called the auto tracker, where the software actually can help you to do the auto tracking. But I try it, it's not very good, because sometimes, especially when the ball get close to background like this, then it cannot detect. Like it's not like the modern artificial intelligence nowadays. This is rather old software, but open source. So it's actually pretty good. I mean, still update, I think 1 month ago, but then don't expect it is extremely powerful. And I don't actually, as a physics learner, I don't recommend you to use it anyway. I'll still recommend you to just simply point all the points by yourself. So you can just ignore it. For the next one, obviously, it's just the diagram. So when you try to choose a point, you may want to zoom in, because that may help you to locate the point much better. Imagine you're doing it with 25%, there's no way you can do it accurately. So doing it with a reasonably large size is actually more helpful for your experiment. So I'll go back to 100 first. So for the next one is to just simply show the trail. So you can actually set all steps. So no matter how you go with the video, it show all the steps, or if you like to show more like shorter trail, they kind of go like this. All right, it's just a matter of display only. It's really like personal choice. For the next one, you can see once I toggle it, it will just be showing the number. So again, it's just a display issue. And again, the next thing will be showing the path or not. And then the next thing will be showing again the point, and well, I do think I will want to know the position, and then the velocity and also acceleration. I think these two will be too much, because yeah, I think we can just tell by our own physics knowledge. So I would just simply keep them off. For these would simply be making it longer, all right, so that it's more visible. So sometimes maybe you want to provide some ideas when you write a report or explain a certain special motion, then maybe it will come very useful. And same for the acceleration as well. And this one is multiplied by the mass. So for bigger mass, maybe it will just be longer. Maybe you want to show it with the momentum. Okay, and the last thing is just simply all the file icons. Again, it's just a display issue. Without further ado, let's start to do our first video analysis. So let's just start with the frame by clicking this. And my advice is you would want to choose a frame that you are sure that the ball or whatever object you are studying is away from the initial device. So here will be the hand. If it is a previous frame like this one, then it would not be a good one, because probably the motion is not in the mid-air right now, so that will be strange if you include that. But let's say we did that. So let's say we try to choose this point. So the way to choose this point, you can see on the yellow tooltip here, is to use the shift click. So once you click the shift button on the keyboard, you can see the icon will change. So you can just adjust the point, choose the point that you want. Again, like I said, if you want a more accurate one, you may want to zoom in, or even 400 to choose probably the center. So as long as you're consistent, it's fine. of the point. And then you can also see that it will automatically move to the next frame. Okay, so you just have to do this for all the rest of the point. So back to the previous one. If you want to say, like I said, this one is not a good one, so how do I remove it? There are actually two ways to do it. One, you can right click it and choose the delete button, or I think you can just click the delete on your keyboard. Alright, if like this one. So I just click the delete button on my keyboard and it just got removed, or you can right click the mouse and you can also remove it. Okay, then it will be removed from your list. Just now earlier we mentioned there's an auto tracking method. So what you can do is you can see actually it's quite clear here. It said you have to press the shift and control and then click the object. So like here. So now you can see it kind of like, I think the mechanism is simply it try to study the image of this and try to find in the next frame. So is there any similar frame for this one? So after you got this, then you can want to click search next, and you can see here it actually helps you to do it automatically. So if you want, you can actually try this, and maybe that can give you a more stable position rather than you just pressing middle. But then things may happen that, for example, sometimes like this one, because the image is kind of overlap with the ruler, whatever it is from the behind, so you can't actually do it. So what you can do is you may want to maybe skip it for this one, and then I think they still can't detect it. So I don't know, should I, okay, maybe I'll just try to let them study the image again. And yeah, I think that's fine. And then go for the next one, go for the next one, go for the next one, next one. We can actually go back to this later on, right? So let's zoom in, zoom out, and then I think the rest will be easy. So that's why sometimes when you do a video, it's better if you can have a clear background, so that it's easier to do this auto tracking. Or if in the lab it's really hard, then I guess you can always do it manually. So for this one, I can do it manually by simply pressing the shift button, and I'll do it by myself. So it's actually right here instead. Okay, so I think that is all. I can close this. So we can check the trace again, or just simply show all the steps. Alright, so this is how we can do it. And by looking at the graph, I would like to check the Y acceleration, and you can see it's extremely strange because the value, even if I zoom out, you can see is not the same as what we had for the so-called model answer, or whatever you call it. It's around -4 or something, and that is actually because I forgot to change or forgot to set the calibration. Like I said, you have to tell the video or the software what the scale is. So let's try to go here and start to click the new and calibration tape. And then again, you have to use the shift button on your keyboard. And actually in this video, I'm not very clear because I would say they should use a meter ruler, and I actually have no idea which one is 1 meter. But by looking at the previous video, I suppose this is from here to here, hopefully. And then you have to key in the value, which is 1 meter, and then and hopefully the whole thing will be okay. So sometimes you may want to click the refresh button so that the whole data will be updated. And let's just take a look again. Auto scale. Okay, that's, I guess, is pretty good. Well, not as nice as the one that we have, but you can see roughly it is also around 10 also. But I think if you can get the Y velocity, I would say it is actually not too bad, right? So I'm actually quite, I would say, quite happy with the graph here. So for this one, you can actually copy it to other software like the Excel or anything. Then you can do the analysis further if you want to. To try to check the slope more clearly and accurately, what you can do is on the graph, you can actually right click it and choose analyze, and then you'll be able to see this. Here I'm showing both velocity for vertical and horizontal, and in fact as a physicist, we don't actually like the data point draw from point to point because those are quite meaningless. We actually want to see the general trend instead. So I would remove the line by unclicking this. I'll try to make the X step one more clear by changing it to maybe say another color, say blue, blue color, or maybe you can change the shape to something else, circle maybe. Okay, it's really up to you. But the most important thing is you can first of all use these two functions. One is to find the slope, but that is more like instantaneous slope, as you can see like this, which on the bottom right you can see the slope here. So for example, this one is at negative 1.02 E1. It actually means that the slope is negative 10.2 because E1 means times 10 to the power of 1. But then this is still instantaneous slope. We want to see the general slope, right? Let me show you one more thing first. This is area, so I guess you can tell quite directly, but then it's not something we want. So in order to find the general one, we'll need to find the key here, which is a curve fit. So what it does is the computer will try to fit a line that fits the general trend of your data point. So you can actually try to use auto fit here. In some situation where the study may be not a straight line, so for example, if you're studying the vertical displacement over time, it will be a parabola shape, so you may want to change it to other mathematical model. Here I'll stick with line, but if you change it to say parabola, you can see here become a quadratic equation. And so let's stick with the straight line right now. And you can see this is a straight line or linear line standard form of the equation, and A is representing the slope. So when we look at here, then we can clearly see that the more justified slope, which means the gravitational acceleration here, should equal to negative 10.11. And if you in a case where you don't find this is very good, you can actually adjust it. You can actually change the increment here. If you say, oh, 10 is say too much, right? This is quite stupid, right? So let's change it to 1%, so 1% increment, or you can even manually input it. Okay, so then to a point, to a position where you think it is fair. Same for the X as well. So you can do the same thing as well and find out the exact value for it. And this will be the most useful part for generating the result. Okay, so that's pretty much for our first video on tracker, and in the next video we'll talk more about some more details about video analysis and some other things you can do with it. So if you really want to try, you may want to go for another video called the cups clip in the library, and you can try to see how different numbers of paper clips can affect the free falling of a paper clips.